Hi, I'm Matt Land, and I'm doing a talk on Python types, especially under the later versions of 3.8, 3.9, and 3.10 of Python. But I think everyone will be included in the strategies I kind of outlined today for typing in later versions of Python. I think things have changed a lot since I first started typing, probably under 3.6 and even under the 2 series. So I want to share that. And if you haven't typed before, I think it's really valuable to people that read your code. It makes it a lot easier to understand your code. And I think that, it's nice doing the static analysis checks that you can do with MyPy and things like that. And I think future versions of Python, adding the type annotations is going to be the way that your code runs faster. Other dynamically typed languages, this is how they've made their code go faster. As they've done later versions of their engines, and I don't see that being any different for Python. So let's just jump right into the syntax today. So left-hand assignment is kind of how, in the past, I think it was done as a comment on the right, but you can just throw your type right on the left. The first 4 examples, you'd probably never do those, but they are valid. It's just, you would just be able to see the types, and so those are probably not real helpful to see. But the bottom examples, when you're initializing a list and you don't know what the types are going to be in the list yet, you can go ahead and decorate and say, well, it's going to be a list of strings like we have here. And for dictionaries, generally dictionaries like the dict, when we compose that little structure there, it always takes 2 arguments. The first one being the type for the keys, which is usually strings, but not always in Python. And then the right side, in this case, I'm saying it's going to be a dictionary of ints. So whatever I'm looking up by keys, it's going to be always integers in this dictionary. And then the third example here, where I have a list of tuples of floats. You can think of that like, well, I'm going to have a bunch of lat-long coordinates. Those are the lat-long pair is a tuple, and I'm going to have a list of them. So this is a way to tell Python and the type checker that this is what you're going to have. And so if you try to put something other than that into this list later, it should raise an error because something's wrong. So in functions, I've got an example here of a function at the top without the types and one at the bottom that does have the types. And I think it does make it more readable once you're used to seeing the syntax. So everything's the same except, next to each argument, I'm telling the type, the primitive type that it's going to be. And then I'm saying that my function is going to return none, meaning there is no return from this function. Technically, that's the null or the none type is returned, but just nothing gets passed back. Same thing with lists, just like we did showed in composing before. The list type of string just gets dropped in there, so it doesn't have to just be the primitive types. And I still have my none return type here. Third example is a dictionary, and just like you'd expect, this one is also returning a dictionary. So you can see it's you can type everything that returns. It's always the same format now for composing these. One of the things you're going to run into, because Python is dynamically typed, is a function can return different types of things, and potentially your arguments can be different types. Probably want to avoid it on your argument types, but you can be doing that in valid situations. So we have this idea of a union, or the union type, which lets you compose multiple types together to say it could be any of this set of things. So I have my function here, and it's doing a lookup on this dictionary, and the values that it can. So we're just going to do a get on this dictionary, and the values it can get out are either string or a float. So I'm going to compose the union of string and float, but I also have to include none in case I look up a value that's not included in the dictionary. And when you do .get and it's not in the dictionary, you get a none. So this is what union of the 3, that's where that comes from. In Python 3.10, they have this new OR operator that lets you just leave out the union operator. I think it's a little nicer, but coding it this way, like on line 11, will work in any version of Python right now. This is another example where I wanted to call out, in addition to union, we have this shorthand for certain types of union called optional. And often a Python function will either return something that you're looking for or return none because it doesn't have anything. So instead of having to always type the union of string and none, we have this optional shorthand to say optional and then whatever the thing is that we could, or, in the best case, we would get back. That's all it is. These are just identical in functionality. It's just a shorthand. And again, in 310, you would just code this as string or none. Okay, so we also have an ellipsis operator, and this is technically only 310, but because this is something that is encountered at runtime, or like the types are not seen at runtime, so this is going to work fine under 3.9. What this is saying here is like I have a tuple of arbitrary length, so I don't have to specify. I can have a variable length tuple, and it will always be floats. Is basically what this is saying is. So my function can take an arbitrary length tuple, do whatever it wants. This is just how you would tell Python that's what you wanted to do. Sometimes you have to work with code that isn't typed, or you're not sure. Like sometimes you just need like an escape hatch, and so this other type called any is where that comes in. I try to avoid it most of the time because you're giving up on all the type checks. There's usually a better way, but sometimes you just have to make a thing work and move on with your day. So that's when any can come in. Like in this case, I could go write my function to say, well, it's going to return the union of date time, float, a bool, an integer, or a string. But that's not really very helpful because it's just kind of a whole bunch of different things. So in this case, it's better just to say, well, it could be anything. One of the other tools that came recently is type alias, and this is built in 3.10, and I will show in the README at the end how to do this for prior versions. Basically, you can do this in any version, but this lets you compose aliases for different types, like maybe your primitive types or something you compose together. Now you can reuse it in your code so that you don't have to keep redeclaring it every time you use some sort of common pattern on a function signature. I use this a lot for like account numbers. Like an account number is a string, but it also has a special meaning that it's an account number. So when someone reads the function, it's more understandable to know that it's something more than just a string. So these type aliases are a typed string, but it just gives it an alias, and so then in your code, it's just more understandable what you're dealing with instead of just facing string everywhere. And you can even take these further and compose on top of these to make your code more expressive and more understandable. I think that the second version down here, like they're functionally identical. But being able to see and decompose like what these things are is a lot more like I can understand code I haven't read before, which is I read a lot of, versus just having to go pick apart, well, what are these strings? Where are they coming from? What are the types of values? I just know a lot more when it's like, oh, by name, or just some sort of, something for humans to understand it better. And the last thing I was going to talk about today is about duct typing and inheritance. So often you're going to have generators that you want to type, and it's a great way to write a function. But I think when you have to do the generator type, it gets a little gross because you've got this. I don't even know what the three arguments are. I think I know the first one inside of generator, but my code is going to treat it as an iterator. Like generator is an implementation of an iterator. So that's generally good enough for your types. Just don't be so specific. Just say it's an iterator and keep it generic. Same thing if you're if you have like a meta class and you could have subclasses, different subclasses of it, you don't want to say the specific subclass. You want to say whatever the meta class is, whatever the most duckish thing that could be in that situation. That's what you want to say. It's going to be an instance of that, so that your code isn't bound to some concrete class. Okay, so again, if you can do 3.10, I guess with like everyone shipping Docker now, it seems like I get to ship the latest versions of Python a lot more often because I'm always patching CVEs, but that only came out in October. I think a lot of people are still running older versions. So if you're running anything from like 3.7 forward, almost everything here is available for you to run. If you do the from future import annotations, that gets you all of the native types instead of having to do the uppercase. I'm going to import a dictionary. Like, just do that, and it makes makes your code work in future versions and your current versions now. And then if you need type alias, if you have 3.10, you can just import it. But otherwise, you're going to have to install this typing extension package, which does a whole lot for different types of things. The type alias is the only one I really covered here. So I hope you give types a try, and I hope you have a good conference.